We are already aware about Alex's profile, so I'll just very briefly repeat this little part.
It's me again. Actually, previous presentation was developed by my TRIZ teacher and current boss, Simon Litvin, but he experienced some passport problems. That's why he couldn't participate. He asked me. And this is my presentation about technology forecast. Because I told you that our methodology is applicable for different purposes. Previous one, I demonstrated how we can apply it for some conservative purpose, because cost reduction is kind of very conservative situation, right? But there is another situation. You could say, you know what, we don't care about current situation. We know how to address current problems of our system. But we need to know what will happen next. What could be next generation of our products or our technologies or our services? And we can apply our methodology for this purpose. And actually tools will be the same. The same function analysis, the same cause and effect chain analysis, the same trimming. But we will use them differently. We will adjust them, not for immediate system improvement, but for long-term forecast. It's green, but it doesn't work.
Wait a minute. Yeah, okay. What happened?
Push. Okay. Oh, okay. Now it works. Good. This is agenda. Just a small introduction. We will discuss some existing methods and what is wrong with existing methods and what is difference between existing methods and our method. After that, I will describe how different tools, already familiar for you, could be applied for this purpose. After that, I will use case study and the most interesting part, questions and answers. Okay? This is a definition of our forecasting. And once again, guys, we do not forecast numbers like after 20 years planes will have speed 1,500 kilometers per hour. No. We try to forecast design, how we should make this plane to be so fast. Okay? Our forecasting, it is a solution. It is like high-level solution, not without details, but we answer not to question what, but to question how. Okay? And there are a number of existing methods. For example, there are so-called normative methods. Actually, it's rather planning than prediction, right? You can plan, okay, we will do after 5 years, after 10 years, we will do this and that. And actually, they're not predictive. We just make some planning. And they're kind of subjective, because how do you plan? You ask experts, what do you think? What can we do? We can do this and that. Okay, let's do it. But, you know, experts could make mistakes. Research methods, for example, analogy methods. For example, we look at the system, but there are analogous systems, and these systems are more developed, right? Okay, let's see, this system developed in this direction, probably our system will also be developed in the similar direction. Once again, analogy could be superficial. You know, they look familiar, they look similar, but situations are quite different, and this system will not go in the same direction. Extrapolation methods, there is a lot of mathematics there, but sometimes they lead to terrible mistakes, particularly because they do not predict quantum leaps. Right? Because the system can change dramatically, but extrapolation just makes like a smooth curve. But we could have this type of curves. And expert evaluation. Let's ask let's everybody in this room and somehow apply some mathematics to just to process information. As a result, we will have some average expert opinion. Once again, you are aware about psychological inertia, right? And experts also have psychological inertia, and they pretty often make mistakes. Here we have these disadvantages of existing methods, particularly accuracy of these methods. They are pretty high if we are talking about short term, but we lose it dramatically if we are talking about long term forecasting. Okay? Especially, these are the most kind of terrible disadvantages. For example, you are approached with this guy, and he said, you know what, we produce these products. What would you suggest us? How to occupy more market? How to improve our system? What would you suggest them? Well, what can we say? All these systems are obsolete, right? It doesn't make any sense to try to improve them. Just another, it's kind of well-known example, it is extrapolation method. They just made prediction that, after 50 years, the main problem of London will be just horse manure. It will be covered with kind of 4 meters of manure. It's kind of pure mathematics, right? We make extrapolation. How many people will we have? How many horses do we need to transport them? What manure? That's it. But guys, it was 1894. In that moment, first cars already existed. But these people who made this prediction, they ignored this fact. Okay? I hope you know these persons, right? It's Karl Marx and Friedrich Engels. And once Friedrich Engels, he considered himself as a great kind of specialist of forecast. And he said, you know what, in terms of military systems, we have machine guns, we have very effective artillery systems that shoot to the distance of visibility. It means that wars are impossible, because any number of infantry could be wiped out with machine guns and artillery. No more wars. Is it true? But after a few years, first tank was invented. Can you see? Just, great specialists of forecast used to make terrible mistakes making the predictions. And what about our methods? First of all, it is MPV driven. We already discussed what MPV are, right? Main parameters of value, and we take into consideration what parameters should be improved, and we also think about future parameters. Right now, people don't care about it, but in the future, it will be important. Okay? And once again, not only what, but how. For us, prediction means solution. High level, without detalization, but it should be solution. Okay? And of course, we use trends of engineering system evolution, because trends just describes how system used to evolve. And if all systems evolve in this direction, probably your system also will be evolved in this direction. But we don't use only one trend. We use a number of trends together, and they lead us in one direction. For example, I have an analogy. This is kind of existing methods of prediction. For example, we have this billiard. Can you predict position of balls after just first collision? Yeah, you can use simple formulas, right? And predict where we will have these balls. Okay, let's make second hit. Can you predict again? Yes, but there will be some mistakes, right? Because your formulas are not completely correct. You don't take into consideration some minor parameters, right? After third, after fourth, after fifth collision, you will not be able to predict exact position of balls, right? That is why accuracy reduces in time, right? But what about our method of forecasting? Let's imagine that we just put one book under the leg. And let's imagine that we have not flat surface, but rough surface. And we have balls with different diameter, different weight. Can you predict position of these balls after first collision? No, because you know the surface is rough, balls are different. You have no idea, right? But can you predict their position after 10 collisions? All of them will be here, right? Do you understand the difference? Because trends of engineering system evolution, it is like a constant force, but it is pretty weak force. That's why on short, if you're talking about short term, some other parameters could disturb, economical, psychological, whatever. But sooner or later, these trends will push your system in this direction. That is why accuracy of our forecast increases in time, and the classical method just reduces. Is it clear?
Yep.
Good. Yeah, MPV and other techniques. Just what tools are we going to use? The same tools, but with some. This is just our typical roadmap of our project. You can see there are a lot of tools. That is why when we teach people, we spend a lot of time teaching it, because, guys, I learned it during 2 years. I can teach you much faster, but still it takes a lot of time, because look, we have a lot of tools, and inside each tool there are some sub-steps, and for each step we have algorithm. It's a big story, right? But it works because also these tools somehow overlap. If you didn't find solution here, you will find solution there. Okay. For example, we start from benchmarking. We need to compare different systems and select the best one, right? But if we are talking about forecast, of course, we need to compare not only very pretty identical systems, very similar, but also we can include systems existing in form of patent or in form of lab prototype. And because right now they do not demonstrate good results, but probably they have a huge potential, and we just include them into the table of benchmarking. Also, we apply SCurve analysis. It's a big story. When we teach SCurve analysis, we spend about 3 days only for SCurve analysis. But here we just look at, okay, our parameter now on the first stage, and we can predict what will happen on the third stage. We can predict development limits, and we can say probably doesn't make sense to go to improve this system because development limit is too low. And there are different types of development limits. It's a big story. And of course, we use to compare systems existing MPVs and predicted MPVs. How to predict MPV, it's another story, because some MPVs are well known, and it is necessary to improve them, but some of them are hidden, and we have special technique how to identify these hidden, unknown potential MPVs. Well, function analysis. Here we have some nuances of component analysis, which is part of function analysis. For example, your system, you're going to predict how the system will work. But the system should interact with super system, right? With what super system? With existing? No. It will interact with future super system. That is why before you will make forecast of your system, you need to make forecast of super system. But to make forecast of super system, you need to make forecast of super system. And theoretically, it is impossible, right? But practically, you could say, you know what? Probably for this horizon of prediction, this super system will not be changed dramatically. But first of all, you need to make brief forecast of super system. And after that, you will try to adapt this system for the new future super system. It's a big deal. It is not easy. A lot of mistakes could be done here. But guys, life is tough. We should do it. Okay, cause and effect chain analysis, of course, as a target disadvantage, we can select just insufficient MPVs, even future MPVs. Right now, nobody cares, but in the future, people will care. Of course, evolutionary trend analysis. Usually, we use next steps. Our system is here. Let's try to make next step. If we are talking about long-term forecast, we should go far, far away to the very end of each lines, because there are a number of lines, and we go to the very end and we make prediction. Okay? And trimming. Of course, we will not apply conservative trimming. Okay, let's try to trim 1 or 2 components. No way. Let's trim a lot, and probably let's trim component responsible for action principle. It means we will change action principle of the system. And feature transfer, function-oriented search, actually there are some nuances. Guys, you didn't learn these tools, that is why description of nuances are not very interesting for you. Probably we should go to case study. Because it is just theory, let's use a case study. It was 1997. Procter & Gamble asked us to make prediction of washing machine. They told us, guys, don't try to improve existing washing machine. It's okay. Would you tell us what will happen in the future? What could be a future technology of washing? Okay, let's try. First of all, we started from SCurve Analysis. And as MPV, it is effectiveness of dirt removal, right? And we decided that current action principle, this chemical action principle, when detergent removes dirt from the surface of the fabric, it is on the 3rd stage. Because, guys, modern detergents are very good. And if you try to improve them, you will not add significant functionality. That is why they usually add some, improve some new MPVs, like add a good aroma or something like that, but good packaging, but they don't change formula because you cannot improve efficiency anymore. But we are talking about long-term forecast, right? What conclusion should be done? We need to change action principle because this chemical action principle is exhausted, right? If you would like to make something significant, you need to change action principle. What principle, we don't know yet, but later on we will define it. Just market trend analysis. You know, there is well observable market trend that everything should be environmental friendly. Right? Probably less effective, probably more expensive, but it should the environment should be preserved. Do you agree with me? Right? But guys, if we apply detergents, modern synthetic detergents, they exist in the nature during hundreds of years, and it's a lot of contamination, right? SCurve Analysis recommended us to change action principle. And this market trends also recommend you, guys, don't use detergents. Okay? In the future, probably there will be more legal limitations, like don't use them at all. Okay? Good. Function analysis, simplified. Actually, guys, even modern detergent do not remove dirt well, good enough. That is why we add excessive amount of detergent. Look, physically, what amount of detergent actually removes dirt? Just few percent. And all other detergent we add just to be sure that all dirt will be removed. Extremely excessive amount. Because effectiveness, actually, not effectiveness, controllability is insufficient here. Also, fabric holds dirt too much, right? And if you apply flow analysis, we didn't discuss flow analysis with you. It is a very interesting tool. We observe how different flow of energy, flow of substances, and even flow of information go through system. And these flows have some typical disadvantages, and we identify them and can use them for cause and effect chain analysis. Particularly here, we have a so-called gray zone, because we have no idea how detergent interacts with dirt. We don't know, we cannot control. You just add detergent and that's it, right? And use the drum. No control. That is why we add excessive amount. And cause and effect chain, simplified. Okay, we have a problem that detergent contaminates water. Why? Because we have excessive amount. Why? Because we insufficiently use this detergent. Why? As a result, you know, there is adhesion between dirt and fabric, and we don't know property of this dirt. We know property of fabric, but we don't know property of dirt. That is why we have excessive amount of detergent. And trimming. What is the best detergent? No detergent, right? Okay, but we need to delegate function to somebody else. If there is no detergent, who else do we have? We have fabric and we have water. Let's delegate function to water. Water has to remove this dirt, right? And if you apply standard solutions, what do we have here? We have dirt, we have fabric, and we have adhesion force, right? We call it harmful subfield. Subfield means substance field model, right? And if you have some such harmful subfield, there is a standard recommendation, typical solution. If you have two components and they interact harmfully, you don't like this interaction. How to destroy the subfield? You need to add second field. And second field should overforce the first one, okay? What field could overforce this adhesion? We decided to use ultrasound because we have water, and water conducts ultrasound very well. And this ultrasound can detach particles of dirt from fabric. Particularly, look, and also each particle has its own resonance frequency, right? And particles usually have the same, relatively the same size. It means relatively the same resonance frequency. And if you apply ultrasound on the resonance frequency, you will very effectively detach particles of dirt from fabric. Guys, you can use cold water, no detergent at all, and all dirt will be removed. And we offered this solution to Procter & Gamble. What happened next? Procter & Gamble ignored our recommendation because actually they don't like machines. They prefer something disposable, right? They like to sell water, air, something like that. And we recommended them to develop new types of machines. They said, okay. But what happened next? In 2001, after 4 years after our prediction, this company, Sanyo, developed first ultrasonic washing machine, which could be used. You can use cold water, no detergent, very effective. After that, Procter & Gamble decided, oh my God, and they tried to develop something. They made very small machine. Just you can apply it like that. Just, but it was not breakthrough. Let's say not disruptive technology. They missed momentum, guys, because trends are objective. Unlike our laws, you can violate them. But like laws, you will be punished because if you do not follow them, others will follow. Okay, and you will lose momentum. And look, what kind of, we have three-dimensional forecast prediction. One axis is MPV. We need to improve our system in terms of some MPVs, right? Second axis, market trends. We should follow market trends. We should not violate them, right? And third are our trends, evolutionary trends. We cannot predict exact trajectory. Remember my example with billiard, right? We cannot predict trajectory. We cannot predict time. But we know for sure that sooner or later it will go here. Is it clear? Of course, it's very kind of fast presentation. I cannot teach you, during 30 minutes. But at least you can see how it works, right? And now it's time for question and answers. Yeah.
Thanks for this nice presentation. Very straightforward question. This ultrasonic cleaning is very, very well known from maybe many years. And cleaning, I'm talking about in general for metals or whatever. And you adopted this technology, or that was a future prediction. So that was all nice. But in 2001, there was a model with ultrasonic cleaning. That's also the realized. But today we don't see that much in the market, that it has not changed completely the system that now it's in 2018. We are not having only ultrasonic, and detergents are all over. And so how this this future prediction seems to be realized, but it has not hit the market.
I would say it still is not very successful, because you know what? Prediction is prediction, it is correct, right? But first product usually has very low level of MPVs, because it has a lot of disadvantages. But it has a huge potential for further improvement. That's why sooner or later, probably it will be developed. But guys, actually there are other trends. For example, there is a huge trend which leads us to the area of disposable products. And for example, we could use 3D printers and new materials to make some disposable fabric. In this case, all these predictions will be incorrect, because we will not need to wash anymore. It is another story. But actually, at least we can observe that actually the system we predicted emerged on the market. Okay? But there are other trends. Guys, prediction is my preferable topic. I could spend about 1 week discussing with you different aspects because there are so-called pendulum trends. Trend moves in one direction, but after that it goes in opposite direction. And for example, the same situation with washing. May I spend a few minutes? Remember from what point it started. It was kind of a home process, like women seated just, washing stuff. After that, what happened next? Just professional laundries were developed, right? And nobody did it at home. You just, deliver it to the laundry, and professionals will do it for you, everything, right? What happened next? One very smart woman invented a washing machine. And again, a majority of people now don't use laundries because they have the washing machine at home. By the way, in the past, there was a moment when people from Australia sent the dirty fabric, dirty stuff, to Cuba. On ships, believe me, because of very cheap, labor there, they deliver there, they wash there, and transport it back. Now, practically nobody uses laundry. Now we use washing machine. But look, now we have pretty good developed and with good potential drones and driverless cars. It means any delivery costs virtually nothing. And probably pretty soon, again, you will not make your home washing process, because it's much easier to call. Drone will take this stuff, deliver somewhere, you will know where, and deliver back clean stuff. Can you see this pendulum trends? And we can observe it everywhere. And it's very interesting topic, but sorry guys, I just demonstrated some simple example.
Yes, I agree. Only I wanted to say that is the prediction was done, but that prediction only just realized. So it's almost now 17 years, but today it's still. So the prediction of future, it's how successful it is. That's a question.
Actually, I think that there are some secondary problems. First of all, the system itself, probably, because, guys, by the way, it's all the time. We have a SCurve, right? A SCurve, and now we are on the third stage, we cannot improve system anymore. We need to jump on the new one. Like when you jump to new one, you will jump down. For example, let's compare well-developed horse carriage and first car. Which one is better? Of course, carriage is better. You know, it is faster. It can transport more cargo to longer distance, right? And this car is very ineffective. We jump down, but you know, car had much better potential. That is what sooner or later. And once again, the first jet plane was less effective than the propeller planes, and so on. The first steamboat was less effective than T-clippers. It's all the time, and this machine, it is first one. It's like a baby. You know, of course, the large dog is much more powerful than this puppy dog, but it has much better potential. That's why sooner or later, if other trends will not, intervene, we will observe these systems everywhere.
Just to add, there's one more aspect of the trends is what wins at the end in the market is also very strongly dominated by capitalists. It's money which dominates everything. A very simple question. Can the fish start fighting with water? Are you getting my point? The detergent industry and the washing machine industry are the same. You cannot create fights where one of them wins over the other. So a lot of times there can be technical viabilities which are possible, but at times it is capitalist goals which win more, and hence they decide to kind of subdue certain technology. So this is a natural phenomena, and this happens all the time. For example, when VHS came into the market, there was Betamax. Who won? Betamax was better, VHS won. Why did they win? Because of the lobbying, etc., which was there. It again happened with Blu-ray technology. There was another technology which was far superior than Blu-ray, but the Blu-ray won. So if you go down, there's a lot of these paths which are there, but as we say, technology evolution is one side of it, but you also have to look at some of these patterns before you start seeing what can likely happen. So that's a different topic by itself.
Contribution from the so prediction of market.
Yes, also is yes, absolutely. So you have to do it's as Alex said, it is an intersection of all predictions which are there. It's not one by itself. So you have to do the market. That's why he showed you the three-dimensional part. And then which are likely, as he says, it's likely. Now when could this be likely is just imagine if the industry which is there is completely gone. For example, there is no washing machine industry itself which is going to be there, or no detergent industry to be there. Only one or two players associated with this there. They might see sense to probably bring it back into the domain. That's one of the reasons you see technologies have been subdued, and when the right time comes, they again emerge back into the system.
I have a question. What is the best presenter? What is the best presenter? There's no presenter, right? How to get rid of presenter? We need to delegate his useful functions to somebody else. Okay, your question. Speak up, please.
Hello. Yeah. I'm coming from the banking industry, and we are facing a huge amount of disruption and innovation in the industry itself. Just to kind of disagree with Shri on that, banking as an industry will not exist 25 years down the line. We are clearly seeing those trends happening, and we are working towards those trends, and banking won't be there. For example, one of the mega trends in banking is the trade. the entire banking channel of trade and payments across the globe is a really huge channel for banking, and that's the backbone of banking as an industry, personal banking aside. Shipping industry on the same time is along the lines working together, and Maersk, for example, is building a huge amount of ecosystem to create a seamless movement of goods and things with ships, which can be done seamlessly across the globe online. If that goes online and banking goes into blockchain and all that starts coming to reality, banks don't want it, but it's a reality that's going to happen.
Yeah, right.
And banks who are preparing for it today, 25 years down the line, can be a part of this new innovation and new journey, otherwise they won't survive. It's very clear.
Okay.
So I just want to say that the trends you mentioned here and the technology which is there, the next technology disruption is going to be in banking. That's what we realize, that a technology company is going to take over banking.
Okay. But what was your question?
The question was, I'm just appreciating that the way you're saying the new trends and the three factors, the market NPV,
Yeah.
the trends and the internal thing, they actually are together. We need to spot them as early as possible and start working towards going towards that.
Yeah, I agree. I agree.
I have a question. In case of NPV, we spot an NPV, but the current cost which is there of the technology may be too high. So then that question always remains is, do you spend all the money and get the technology and because the technology needs a certain curve for the economies of scale to kick in and then the technology becomes viable on a whole, or do you conserve money and come later when it's when the technology is already brought down a bit? So how do you solve this?
Guys, cost is one of MPVs. It's standard, of course. Cost always important, right? Because it affects our purchasing decision. We decide will we pay or not, right? Of course, we take into consideration this cost. But once again, cost by itself, absolute cost, means nothing. For people, the important is functionality over cost. What you will get for this cost. Right? And sometimes we can afford to significantly increase cost of the product if you increase functionality of the system even more. Because, we can compare, I don't know, just remember many years ago, the first copy machines. Just very small, very slow, right? And it could copy one page, per few minutes. And now we have modern copy machines. They're extremely fast, right? But they're huge. Which one is more expensive? Of course, modern machine is much more expensive. But why do we buy this one instead of the old one? Because it has much more functionality. It is much faster. It has some additional functions. It can just staple pages and turn it like that, and so on and so forth. Can you see? That is why cost itself, it is not an issue. The issue is functionality over cost. Okay, and we have some recommendations, because remember this SCurve analysis, it has intimate connection with the trend of increasing ideality, increasing value, and value is functionality over cost. And depending on the position of your system on the SCurve, there are different kind of mechanisms how to increase this value. For example, on the second stage, we can afford to increase cost because we can make functionality will grow faster than cost. And only on the third stage, when there is no ability to improve functionality anymore, because development limit is here, right? But we still need to improve value. Oh, now it's time to reduce cost. And when we make a long-term prediction, we just predict, here we will have this one, here we will increase cost, and here we will increase cost, but here we will reduce cost. Is that answer to your question?
Yeah. I have a question. So far whatever presentation we got, right, the discussion topics more focused on the cost reduction and also the disruptive innovations, things like that, right? So if you also, whatever you discussed right now, so one of the biggest factor is how do you place it? What is the timing? Mainly talking about the business dynamics and business strategy. So does TRIZ also will be able to predict, forecast the business models? Because, yeah.
Well, actually, you have a number of questions inside your question. First of all, it's about time. You know, it's $1 million question. Because we can say what will happen, how it will be done, but we cannot say when. Because when, it depends on some probably not economical reasons, but on psychological, financial, political, we cannot say when. First. Second, about business model. Actually, you know, we developed some methodology about disruptive innovation. And remember, Oleg told you that there are disruptive technologies and there are disruptive innovations. And these are two different stories, because sometimes you can make really disruptive technology, but it will not be disruptive innovation if you have incorrect business model. Frankly speaking, TRIZ experts are not very good experts in business, because guys, we cannot be experts in all areas, right? And we don't try to be a business expert. What we try to do, we develop like adapters, like connectors between our domain and business domain. In my example, they will, remember, we try to predict business impact to make business case, but it is just connector. And after that, we just, okay, guys, after that you know what to do. You're better experts than we are. Okay? And also about disruptive innovation, actually, I completely disagree with Oleg. He's a friend of mine, but I disagree with him. It's another. I guess I know what disruptive innovation is and how to predict it. And actually, it is part of prediction, because you know, in most cases, disruptive innovation is not breakthrough innovation, because breakthrough costs a lot. What does it mean to change action principle? Okay, let's change action principle from this chemical detergent to ultrasound. It's a big deal, right? You need to spend a lot of money, it doesn't, and who knows, will it work or not? But if you make very conservative modification of your system, but we need to get a large result from this conservative modification. But let's imagine we have two systems or two technologies. This one is very good and this one is very good. But they cannot work together because there is no connection between them. And if you develop very simple, very conservative technology which will connect these two, you will have disruptive technology and disruptive innovation, because everything will be changed dramatically, especially if this connecting technology will provide you access to new resources. For example, Oleg told us that Uber is not disruptive technology. I believe it is disruptive because look, before there were two kind of systems. There were a number of potential customers who need to be transported, right? And there was a resource, people on their own cars, right? But these two systems couldn't meet each other. Sounds paradoxical, right? But and what Uber did, it made very simple, computer system which could connect these two systems. And now we have, look, and taxi companies are furious about it, right? Because this Uber system is much more effective and much cheaper for people and more profitable for drivers. Okay? And we can predict such disruptive technologies. And if I have a few minutes, I would like to offer you some example, historical example. You know, in the past, on the south of United States, the major culture was cotton, right? And you know, there are two types of cottons, green seeds and black seeds. And one seeds are very kind of smooth. It's very easy to remove them. That is why they used slaves. And slaves pretty fast removed these seeds, and they used to sell these cotton to English fabrics, because in England there was industrial revolution and they needed a lot of cotton. But this type of plants could be cultivated in very, very narrow area. And there is another type of cotton. It could be cultivated anywhere, but it has seeds with some hooks. That's why it is very difficult to remove these seeds. And that is why, for example, typical slave could produce just few pounds, 1 kilogram of cotton during one day. And it was so ineffective, and they decided that it doesn't make sense to do it. Owners of plantations decided just to release their slaves after their death. They just signed papers that we don't need them. Probably slavery could disappear automatically because of it was not profitable. But there was one guy who was not expert. He visited south, and he was told, you know what, there's this problem, we cannot remove seeds from the cotton. He went home, and he developed very simple system, just a wooden box with handle and 2 drums. But these drums not rotates like that, but rotates in the same direction, and there are some pins on these drums. And if you rotate these drums, you put cotton there, and these drums just remove seeds very effectively. And he demonstrated just in front of them. He just during a few minutes made just 1 kilogram of cotton. Is it breakthrough? What? Just piece of wood, just with handle. Very simple system, very low toxic system. Results of this innovation. Result, first of all, slavery in the United States, existed 70 years more. It provided prosperity of South, because production of cotton grown, 10 times, 20 times, 100 times. Due to prosperity of South, there was civil war. And as a result, history of United States, and actually history of entire world, was changed, because this guy invented this wooden box. If you visit modern fabrics, you will see exactly this system. But instead of such system, it's multi-meter rolls with electric motors, but the same 2 drums with pins. If it is not disruptive innovation, I don't know what disruptive innovation is. Can you see very conservative solutions? But why is it disruptive? Because there were 2 well-developed systems. There was a system which cultivate cotton, right? And English fabrics producing fabric. But there was no connector. They couldn't interact. And this very small piece of wood just worked as a connector. And guys, we know how to predict disruptive innovation, and we include this methodology to our forecast technique. Is it answer to your question? Good. Any other question?
Yeah.
Thank you.